Kviečiu šios konferencijos svečią iš užsienio paskaityti paskaitą. Tai yra Marko Ingrassia, architektas, Katalonijos pažangios architektūros instituto mokslininkas. Jisai mums papasakos, kaip savo mokslinėje įstaigoje yra derinamos pačios naujausios šiuolaikinės skaitmeninės technologijos pagerinti, atnaujinti miestų struktūrą ir miestų gyvenimui. O tą struktūrą ir gyvenimą mes paveldėjome iš senų laikų, kaipgi tos struktūros prisitaiko prie šiuolaikinių poreikių, šiuolaikinių tempų, naudojant skaitmeninės technologijas ir kokią ateitį galime matyti mūsų miestuose netrukus. Paskaita vyks anglų kalba. Paprašysiu pasveikinti mūsų svečią. Please welcome to the stage Marko Ingrassia.
Thank you very much, and good morning, everyone. First of all, I would like to thank the organizer of the event, the entire fantastic team of the STRUCTUM magazine, as well as the Architect Association of Lithuania. I will be speaking in English. I took some of my Lithuanian is not as good enough yet to understand fully the content of the previous presentation. Nevertheless, the topic of the entire discussion on technology and innovation is crucial, and it's something that appeared throughout all the presentation. And it's crucial to understand how new technologies and new innovative processes can radically change the way in which we design, but also how we inhabit our built environment. The technology that I would like to talk today is not only the technology and the innovation and the technology in construction, but also the innovation in our economical, social and cultural behavior, which are already changing the way in which we inhabit our behavior. So we can say that we live in the digital revolution, but we still live in cities, and we inhabit cities and buildings that have been shaped by the Industrial Revolution. Modern architecture was able to give an answer to the needs of industrial society that was based on standardization and mass production, the same model that we still have today, a model that was able to give an answer and increase the life quality of the majority of our population, but it's actually at the basis of the current environmental crisis. It's a consumption model based on extraction of resources, on the production of waste, but at the same time on the generation of pollution. And as I was saying, this is creating and generating the current environmental crisis, putting at risk our self-capability to still inhabit the world in the way we were used to do, but also putting ourselves as designers in the position of say, okay, should we change the way in which we look at design and the buildings? This is a bit something that we talked about. I think that when we talk about the built environment, we have to be able to really understand how we have shaped cities that have been made for car mobility, for car transportation, cities that are made with zoning. Mainly of our cities are made with central city centers surrounded by big peripheries, some industrial districts, but mainly residential areas. So when we look also at our building, at the way in which we design today, we start to realize that yes, we are making a lot of advancement in the way in which we design, in the forms, in the performances of the building, but at the same time, we are still, if we start to remove what are the the technological layers of our building, we still are designing with the skeleton of the machine for living. You can recognize the project by Le Corbusier. It is exactly made 100 years ago. So how should we change? How can we make a step from this and change the way in which we design, we look at architecture today? So the risk, as I was saying, is not only the environmental crisis. Architecture is responsible for a big amount of the pollution of our human activities, but also the obsolescence of our buildings that should be able to really fully take advantage of what are the technologies that are changing the way in which we inhabit, we as users use the space. So I would like to point out some of these technologies and that can radically have an impact on our design. So one of these, first of all, it's something that it's already changing the way in which we inhabit. Wearable technologies, portable devices, and augmenting interfaces. Every one of us has a smartphone in his own pocket. It's a mini computer that can allow us to be engaged and be part of a constant stream of information and data that we can produce and we can gather at the same time. We are part of that. And this is indeed changing the way in which we inhabit, we experience the space. So this is the election of Pope Francis. You can see how the big amount of devices that are creating a filter between the reality and the user, and at the same time are changing the way in which we interact. We can gather information, we can inhabit the city differently according to this information. Same for the buildings. But at the same time, we can have a layer of information directly on the space that we inhabit. We can start to have a different experience of our space. This is an augmented interface, augmented reality interface developed at the Institute for Advanced Architecture of Catalonia. And we can start to look at architectural models overlaying information and allowing every user to interact with the same information. At the same time, we also even have the possibility to inhabit simultaneously different spaces and different realities, to experience them. And this is a virtual reality tools. You can recognize Zuckerberg there. So these are realities, something that has been implemented by technology and will still soon arrive to influence our life. So what's our position in front of this? At the same time, big data and IoT, Internet of the Things, our pockets produce data. This data can be used, visualized, and can change the way in which we interpret our built environment. You can see a representation of London made thanks to the path of the different runners in the city. You can realize that this is changing completely the way in which we look at the built space and the hierarchies, but at the same time, these devices, all the objects that we start to have in our buildings, are every time more technologically based, filled with sensor and elements, electronic devices that can allow a dialogue. So the building becomes to be a computer. More technologies, digital and robotic fabrication. If we look at technologies that are already inside our industries since decades, we start to realize that we can start to fabricate and make our building differently. What if we start to apply this technology today in the way in which we inhabit? But also, we can start to develop complex geometries from bidimensional elements like wood. We can start to create three-dimensional ones, and we can start to 3D print. But we can also transform and include in our building innovative production devices that can go from energy, for instance, solar production, but also to algae inside the building facade. This is a project by Arup, it's called Solar Leaf, in which algae start to produce energy and at the same time have a passive role in the passive environmental design of the building, and have an active role creating energy that fills the building in itself. Or also we can start to put agriculture into our cities. This is crucial at the moment in which the big majority of our cities, of human beings, lives in cities today. And last but not the least, parametric design and simulation tools. So we can start to look, we have the tools today to design architecture as a complex element, not anymore a static one, but a complex behavioral system in which we can start to understand how an object behaves, how the building behaves. This, in this case, is the structural analysis that informs the design itself, but also in terms of energy, for instance. We can realize what is the thermal condition of the building thanks to a continuous monitoring of the building. So we can move from standardization to customization, from consume to produce and making. We can move from linear processes of consumption to circular economy and circular processes, from form to performance. We can move from the building as a machine to living in, as a building as an organism. And this is exactly what we're talking about. If the modern architecture is the answer to the industrial society, advanced architecture can be a way to respond to the digital society and experience and information age we are living into. So with this, I would like to show briefly some of the projects that we developed at the Institute for Advanced Architecture of Catalonia, the IAC, which I'm part of. And exactly this topic that I've been talking about, what represents the challenge that we as architects inside the Institute, as researchers and educators, are engaging, embracing a challenge in order to really be able to look at architecture today, but also understand and research on how we can start to materialize today what will be in the future. If these technologies are changing the way in which we navigate today, we are working together with the researchers and students and companies in order to understand how to test it today. this is okay. So again, where we are located? We are located in Barcelona. So Barcelona, it's a big city that it's hosting the institute, and we are part of the big network of innovation. Also, the city has been awarded the European Capital of Innovation in 2014. And this is also to explain how different technologies and different innovative centers are in the city and are part of our network. And this is our campus. It is a former industrial building, entirely converted to fabrication and to production of new projects, one-to-one scale models, prototypes, but also to education. You can see some of our tools and our classes. There is another building that is entirely dedicated to our students. We have 170 students from 60 different countries coming to study in our masters. And we have a FabLab Barcelona, which is a fully equipped digital fabrication laboratories in which we have different tools from 3D mill, 3D printers, milling machines, electronic labs, robotic fabrication arms, etc. inside the school. So we also have another campus in the forest, understanding how to work with natural resources. So the topic and the way in which we look at design as a complex system and systemic process in order to solve complex questions and give an answer to the needs of today's environment, built space and society, is based on these 3 points. First of all, it's research-based design. So we always work in collaboration with different companies and research centers. We operate as a research center with our students and with our researchers. And every project starts from a question: how can I innovate? How can I respond to a need through a clear process? How can I make a jump and grow in the current process of the way on how we design? Also, it's multiscalar. We move from, we say from bits to geographies. So from the small scale, also the digital realm, to the big scale geographies, the built realm, the physical environment. Moving from the small objects to the infrastructure through passing through the scale of the building, of course, and multidisciplinary. So again, we work with different experts, understanding how this knowledge, their innovation, that specific technological innovation, can change the way in which we as architects design, and can therefore make a complex, solve complex problems with our design. So I wanted to show you some of the projects we are running at the moment. So every project, as I was saying, starts from a question and involves different actors. The first one, it's with 3D printing. We have a lot of work into the field of 3D printing, understanding how we can move from small objects to the real architectural scale, which would be an enormous impact, give an enormous impact on the way in which our buildings influence and generate consumption. And we started actually 5 years ago, understanding what is the best material that has the most potential when moving from the small scale to the architectural scale. We discovered that clay, unbaked clay, has an incredible potential. This potential has been developed even more in a project made 2 years ago, in which we built an entire pavilion in only 4 days during the Fair of Construction of Barcelona. So this is a building entirely made with a robotic fabrication arm, you can see. So it's a robot with the cables that extruded this building. At the same time, drones were monitoring the performance and the quality of the material and allowing a perfect performance in the moment of the production in itself. And you can see in detail. So this was able to support an entire floor in this case. Same for the structural columns. So what if we start to understand how we can apply this into our design process? And again, these are the partners. So big company for robots, the drone and design company that's also a partner of IAC for many other projects, and another one. Then we made something more. So, okay, a building, 5 meters. 5 meters wall that it's able also to support a slab, in this case, so a floor, but understanding how we can give to this material a big and high environmental performance. So how can we work with something that with its design, it's able to work structurally, to generate energy, reduce the energy transmission during the winter, and work as a ventilated wall during the summer. But again, How can we also work with prefabrication in 3D printing? Big, small, build small elements and then put them together to make something real. We had the pleasure to build the first public 3D printed bridge in the world. This is located in Madrid, in a public park. So this is able not only to showcase how we can really put this technology into the reality. It's not the future of 30 years. It's today, but also understand how we can move from a small objects made in a 3D printer to the reality. But it's also capable to take advantage of computational design in order to reduce the consumption of material. The material is put only where the structure needs it. So the structural performance that is studied and optimized also according to the different elements that surround the bridge allow to define the final design, which is not only a fancy aesthetic, but it's looking at performance. But also, how can we integrate a living organism in our buildings and do it on purpose for a positive reason? In this case, we were able to use moss, that I don't know if you knew that, I discovered it a few years ago. We can produce electricity from plants, but also from moss. Moss has the characteristic to grow in the darkness, so where there is not shadow. So if I start to imagine that I use the northern facade of the buildings and I start to put moss, I can create a photovoltaic system that is working with the living organism, and it's able to generate energy from the shadow. What is great, I mean, in the end, this small panel was able to charge a phone as a normal system with the sun of Barcelona. Let's say also with the environment of Barcelona. And what is also important is that we developed this not only as AIAC, but with our students that had this idea, together with the University of Cambridge, who studied moss and the performance of moss, and Ceramica Cumeia, the most important ceramic producer in Spain, which is also a very friend of AIAC, understanding together with the students how to fabricate this and transform this into reality with digital fabrication tools. Or again, same partners, understanding how bacteria can be part of our building. With computational design, we can understand how nature can not only become a problem for our building, but also something positive, can have a performance and allow us to have a smarter building. So in this case, the student explored and designed with computational design and then fabricating in our Fab Lab the nest for these bacteria, so entirely designed for that purpose. So you can see a facade system in this case. Or again, can we produce energy from algae? This is an installation, urban installation made for the London Zoo. And how can we bring this to the city? So when we talk about multi-scalar approach, we are talking about this. We are running a project, a European-funded project, together with many different universities in Europe, in which we will realize, so these are all the cities that are partners, so we will realize in evicted areas, green corridors in which we will start to implement this technology. So all this technology based on nature on site. So this is already a reality, will be designed in collaboration with different partners, but also involving the citizens in the process. Another project with similar topics in which we work with biologists and business schools in order to transform this into startups. At the same time, another topic that I was talking about, production into buildings. How can we work with transforming how our houses and our shelters from consumption system into producing systems, producers. So in this case, we were able to, starting from a question, so can we build a house that is self-sufficient, and can we do it in a Fab Lab? So the project was developed in Madrid for the Solar Decathlon, and you can see that it's a project entirely developed with computational design softwares, in which the parameter is the best solar gain. So we were able to have the best solar gain for Madrid, but the same project, you can download the file from our website. It's able, with the same script, running the software, to have a project for Vilnius, in which the shape would be automatically completely different, or for Central Africa, in which, again, the solar path is different and the house would respond differently. Or again, at the moment in which we design it, how do we make it? And what is the best design to solve and take advantage of a new technology such as fabrication in a Fab Lab, so digital fabrication? You can see that this is made with sections, so the entire design is made working with the section as a structural element. And for a clear reason, all these parts are cut in our milling machine and in our laser cutters. So inside the building of AIAC, they were shipped to Madrid because at the moment there was not a fabrication lab in Madrid. But imagine what would this mean at the moment in which in Vilnius I can download a file, I can extract out of this easily the final project of my house, I can edit it, and then I can build it on site in my local fab lab with my local material. This can change completely the cycle of architecture and materials that we are currently working on. And this again was made with different partners. But how then to apply a similar logic, understanding how, this is another project made by us, of course, in the following year, understanding how the same system can work passively and actively. So creating shapes that in the hot sun in Barcelona are fundamental, but at the same time generate energy from the other side. And how this can be controlled by a software, and how this can afterwards be applied on the entire building of our ensanche in Barcelona. So at the moment in which we, as I was saying before, we live in cities that have been made by the Industrial Revolution, how can we retrofit our building taking full advantage of these technologies? The last project that I wanted to show, I will go very fast on this, it's a project for the public space in which we've been working, again, looking at city as something that can have a new meaning, also thanks to the technology that we have today, with a specific case of the superblock called Superilla. So a superblock, it's a transformation made by the City Council of Barcelona, transforming 6 streets of the city in every 9 blocks into pedestrian areas. This is a project that had a different reaction from the neighbors, and you can see that there were people in favor, people against that, and we started to question, okay, how can we take full advantage of a project that is positive, but also involving and engaging the citizens in the process. We generate an interface that is working as a game, but it's a serious game in which the citizens can start to design their own space, understanding the impact of each activity. If they keep the balance between accessibility, economy, productivity, ecology, and social and culture aspects, then they can win or not the game. But so not talking about the final design, but about the performance and the impact of each design. This is what is very interesting also for us as architects. At the end, we were able to gather data on the citizens' need, on where they are interested to have projects. So this data was also given at the end to the municipality of Barcelona, that was a partner of the project, understanding how in this specific area, those squares in the middle, were really interesting for the citizens in itself, and what kind of project did they want to have. Then this is another data representation, and this was applied in other 2 places, so also multiplication of projects. The last question is how to make this real, how to transform this not only into one-to-one projects, into prototypes that exist, but also have an impact on the industry, which is something that, of course, it's crucial to have a real impact on reality. We are running a project that is called InnoChain. It's a European-funded project in which we work and collaborate. These are all the partners. So we have a big network of academy, and at the same time industries, understanding how to shift and move all this knowledge not from research centers into reality. So you can see big offices that are starting to apply our projects developed in collaboration between the different teams into the reality. And this is, what? Okay, so also robotic fabrication starting to be applied to facade system, to production system, etc. Everything running with our students. So, and with this I wanted to conclude with just a simple, basic, banal sentence, a banal topic, that is the design. At the end, it's the design as a specific methodology that we as architects are very lucky to know how to work with, that is able to gather the entire complexity of different needs, different users, different actors, and different technologies and different possibilities, and join them together in order to let our discipline grow, but also change our world. So what we try to do with our master programs and our work with the students, it's really train change makers, giving them the possibility to have a fantastic impact on the world we live in. So with this, I wanted to thank you for your attention, and of course, if there are questions, more than happy.
advanced city doesn't deny the structure of inherited industrial city. So it's kind of a layering things on the existing structure. So one layer is design and innovations that we can touch and see. Another layer is the digital one that is not visible. How can you say that a city is advanced already? Is it visible? Can you feel it somehow? Is there some limit?
So, on the one hand, it's the citizens are inhabiting the city in a different way already, thanks to the technology that they can have access to. And this is the main big element. Then we have big companies that are working with this very famous model of the smart city, in which a technological layer is applied, a very top-down process. What we want to, and what I think is crucial today, is to understand how this process can happen, involving architects into that, because we have this capability to engage different actors and different aspects of the projects, and transform, allow this digital layer to have an impact on the way the continuous renovation of the city is made. So transform this digital realm into a physical realm. Design experience of the citizens, design the life together with them, but also being able to change the physical aspects. Because the problem is that if we start to build, and we keep realizing and materializing our projects with technologies, but that are current technologies, but with old models, that will not be a catalyzer of innovation. We will still work in a model that is not efficient. It's putting a risk in general the way in which we were used to inhabit.
Thank you. Auditorijos paprašysiu klausimus pasilaikyti po paskaitų, kadangi mūsų laikas spaudžia. Thank you, Marko, very much. Ir aš perduodu mikrofoną konferencijos organizatoriams, nes baigiu šiandien savo moderatorės darbą, tačiau konferencija nesibaigia. Gero laiko.